everyone. Welcome to another episode of Next Gen Scientist at the Institute of Science and Technology, Austria. I am Ana Rita Cavaco, I am your host, and I'm here to bring you the amazing science and here at ISTA and the stories of the people who do it. Today my guest is Achille Jouberton. He is a PhD student at the group of Professor Francesco Pellicciotti, and he will tell us everything about becoming a hydrologist. Hi, Achille. Welcome and thank you for being here today.
Hi Anna, thank you. Hello everyone. I'm happy to be here today.
So, before we dive into what it means to be a hydrologist and how you became one, let's start with our round of 5 quick questions. Ready?
Yeah, I'm ready.
Okay, so one word that describes your research.
Snow.
Very good. What is your brain fuel? Caffeine, snacks, memes, or just straight up panic?
I don't drink coffee, but I have a lot of snacks usually in the office. Yeah, snacks and checking weather forecast.
Okay, a very important option that I didn't have here.
Yeah.
And what's the most unexpected place your research has taken you?
So probably Nepal and Tajikistan to study the glaciers, but also Lisbon and Barcelona in Spain and Portugal for conferences.
Yeah, so you've been all around pretty
Yeah,
much.
quite a lot. Yes.
And are you a night owl or an early bird? Where do you function the best?
Early bird, I think. I like to go to bed quite early.
Yeah, that's interesting. And for last, complete the sentence. I never thought being a scientist would mean...
Oh, that's a tough question. Yeah, spending so much time in front of the computer, but I think that's how most jobs are nowadays. Yeah.
That's very true.
Yeah.
Very good. So before we take a look into your work, just fill us a bit in on what you do as a hydrologist and a bit of also what we are about to see.
Mm-hmm. Yeah, so what I do as a hydrologist is that we study the water cycle in mountain regions, so high mountains where there is a lot of snow and glaciers, which are changing quite a lot in recent years and will change in the future. And we basically want to study those environments. And for this, we basically use our computer simulations, so trying to reproduce how the environment is working using like a calculation and representation in 3D of the environment. And then we also use like data that we collect in the mountains ourselves, and also satellite data, because satellite, they have a very good overview of huge mountain areas at once. Yeah.
Very good. And we are here surrounded by some of the material that you use when you collect this data that you just talked about. So would you like to show us some of the items?
Yeah, definitely. So I brought you quite a few small items today, so small and not so small. So this one is a walkie-talkie. So we usually go to mountain places where there is no signal, no network, no internet. So to communicate from one to the other, we just give to each different team a walkie-talkie, and then we can check in like at lunchtime or in the afternoon. Are you fine? Is everything okay? And then see you later tonight at base camp. So that's very important to have, also for safety. This one is like a very electronic device. It's a data logger, which means that this is something that will collect and store the data as numeric files, like Excel files or text files. And this is connected to many different sensors, which are gonna measure like air temperature, solar radiation and precipitation and stuff like this. So this is like the brain of a weather stations, and this is like something that takes a bit of time to learn how to use. It's quite complex. Something completely...
And I'm sorry,
Yes.
just to interrupt. So you collect the data here, and then how can you retrieve it?
So there is basically a USB port. So you put your USB key, and then the data is transferred to your USB. Or there is also a button Wi-Fi, and you can connect to Wi-Fi to your phone or your computer, and then
very
download
well.
the data. So at least this is quite modern.
Yes.
Okay, something completely different. So this is an ice axe. Usually it's made for mountaineering and to like climb steep ices and snow slopes. But actually we use it a lot in other use. So for example, this can be used to dig something, like if we only have this, to dig like a hole for the toilet, or to dig some debris to make either to make some measurements, or also to make, if you're camping on a glacier, you want to make something flat, so you use this to like break the ice or stuff like this. And if you encounter some angry dogs, this is also a nice defense weapon. I always have to.
Well, that is unexpected.
Yes, exactly. I always feel safer when I have it with me walking around.
But do you actually have to also use it for climbing at some point? No.
No, usually in the fieldwork that we do, we choose places that are quite safe to access,
Okay.
and we don't have to climb very difficult stuff. It's usually just normal hikes. So yes,
Very well.
we don't. Yeah, it's usually not. Another thing is a camera. So we use a lot of cameras that we actually we bring them and we leave them there to take like a time-lapse camera, time-lapse. So for example, we leave it somewhere and then it's gonna take a picture every day for 1 year when we are away, where we're not in the mountain. And then we come back and we're gonna collect the data and see one picture per day, what happened, what are the changes in the environment, like how the snow was in the winter, etc. So that's very cool information to get, and I'm always very excited to come back to see if the camera is still alive and take all the photos and see if there is like an animals being taken in picture by chance or stuff like this. So this is
That
also
sounds also very cool, and probably you also get some surprises out of seeing these pictures.
Yes, we saw like animals, cows and fox, and then one wolf even once. So that was always very exciting to check. Then we have something a bit bigger here. So this is, I don't know if you can see it well, but this is a Kovacs. So this is made to make a hole in the glacier. Because in the glacier sometimes we want to dig a hole to install an instrument or something to measure how the height is going to change from one year to the other. And it's quite simple. Like the bottom here is very, very sharp. And you just have to put it here to turn. And then it's gonna make a hole, and then you can install your things inside. It can be quite intense, like because the ice is sometimes a bit hard to dig a hole, but it's good exercise. And then it's also you don't need any battery or power. This is just manual.
Oh.
Yeah.
A good arm exercise.
Yes. And finally, this is also one thing I really like. So this is just water in a bucket, and we do a lot of measurements in the rivers. We want to know how much water is flowing in the rivers. And for that, we use this product, which is a dye, so which is like something to make something colorful. Like it's like a colorant, or I'm not sure exactly how to say. So I will show you a bit how this works. It's very, very strong. So I just put a little bit in the water. Yes, that's fine. Okay. So I have a little bit of this red powder here, and you can see the water here. And I just need a little bit to make the color completely change. Yeah. So you can see it's kind of flowing down, and then if I mix it, then the water will be green very quickly.
Yeah, it's already starting to be in the surface, I guess.
Yeah, exactly. And so when you do that in the river, and then you measure how the color is changing, then you can calculate how much water is flowing. This is like a chemical and mass conservation equation to solve. It's quite simple, but it's quite a smart technique to measure the water in the river.
So you can see how much water is flowing in that body of water.
Exactly, how many liters per second or cubic meter is another very common metrics.
Very cool and very visual.
Yes, and I think that's it. We also have this small thing. it's called a temperature logger, temperature sensor, and this just measures the air temperature for 1 or 2 years. So you can just leave it somewhere and it's gonna measure the temperature. So you can put it into in the lake or also in the air. And then, yeah, this is very simple. And this is much easier to use than another more sophisticated, and it's also cheaper. You can put them in different places. Yeah.
Yeah, very cool. Now, besides this equipment that you just showed us, I know that we are about to take a look at an expedition that you did to Tajikistan. Would you like to say a few words about it?
Yeah, so basically the video is kind of like a combination of many videos I took over like 4 different expeditions in Tajikistan. And this is, in the end, this video is more like to keep a memory of those times. Also, I use it to show to my friends and family what are the places that we see, and also I put in the video a very local music that we listen to with our local colleagues there, and this is, yeah, I really enjoy it, and I hope you as well. Yes.
Nice. So let's take a look at it and we'll be right back. So, welcome back. We hope you enjoyed this small collection of videos. It seemed that you, besides doing a lot of work, also had a very good time.
Yes.
So, what did you do there, just very briefly?
So there we basically installed a few instruments and collect the data once it's been collected for a year, like what was the weather for 1 year, what was the glacier change, and and we collect the photo of the cameras and see if everything is working fine. That's basically what we do.
Very well. Now, to become the scientist that you are today, first you needed to become an expert in earth and environmental sciences, right?
Mm-hmm.
So when did you realize that you wanted to work in this area?
So I think it was already after high school. I went to do a bachelor in environmental science and engineering, and so it was in Switzerland at EPFL, and then it was very in the continuation of this, doing a master in the same field, environmental engineering, and there you continue to study like fields like geology, hydrology, but also physics, mathematics, and chemistry, a bit of everything, which was very suitable for me, because after high school I liked a few topics, but not sure which one more. So it was kind of like quite broad, but still around these environment topics that I really liked. And And yeah, I think that at that time I realized that it was a topic that I really liked.
So, if I understood correctly, your path towards your PhD now was both a bachelor and a master's degree in earth science engineering.
Yes, exactly. Environmental engineering.
Environmental engineering,
Yes.
yes. And then right after this, you had the chance to pursue this PhD.
Yeah, exactly. So it's quite common at the end of a master degree, you have to do like a small research project, which is in some cases it's also called a master thesis, which is a 6 months where you don't have courses, you just have a research topic, and usually you join a research group which help you with this topic and even sometimes provide you with the topic. And then for 6 months you're gonna do some research on this specific topic, and at the end you have to write a thesis. And in my case, I did this master thesis within the group of Francesca Pellicciotti, which is the group then I did my PhD. Because what can happen sometimes is that you really like the topic of your master thesis, and if it works also well with your supervisor, with the leader of the group, then there is sometimes the options to stay in the group to do a PhD, which means that you have much more time to dig more into a topics and just or do something slightly different. But in my case, that was how it worked out. That there was a PhD position, and then I could continue as a PhD.
That's very cool. But sometimes on our road to become a scientist, sometimes that there are some difficulties on the way, especially I think during a PhD. So what would you say that was your biggest challenge to be here where you are today?
So yeah, I can think of two things. The first one was that when you decide to do a PhD, I think what's very important, obviously, is which topic you're gonna do the PhD about, because you're gonna study this for 3 to 5 years, depending on the
Exactly.
topic and institution. So you have to make sure this is something you really like, and really go in details into that topic, that you enjoy reading articles about this. So at the beginning, I was not too sure about which topic was gonna suit me, but I think after the master thesis, then you realize, oh, okay, this topic looks interesting, and it combines other topics that I like and put them together. So I think this went quite smoothly in my case. And I think another challenge then, which now I'm experiencing rather now, is that a PhD is quite long, not long, but it's a few years of research, right? And at the end of it, you need to come up with your final result and final paper, final thesis. So this is not the easiest part, where you have to say like, okay, what is it that I found? What are my main results? And how to put them together into a nice, like a journal article, and then that you will have to defend them in front of like a committee of experts to then become a doctor.
Exactly,
So
because in the end, at the end of a PhD, we have a story to tell.
yeah, exactly. So yeah, what is it that you found? Like, how will other people remember you from your work and your papers? Like, this is something that yeah, you need to ask yourself quite on a frequent basis when you get towards the end of the PhD.
Yeah, but one thing that I know is that in the end, it all comes together.
Yeah, and usually you have the support from your
Of
senior
course.
colleagues and your supervisor and professor. So yeah, I think usually it goes fine, as long as you have the motivation and the time to put all the additional and last efforts into it.
Exactly. So, on the other side of this, what motivates you the most? What gives you energy in your work?
Um, I think so. We do a lot of cool works using the data that we collect in the mountains, but also the computer works doing simulations. I think since I was in high school or even before, I really like to use a computer. So it's still I'm still in this continuation of like using a computer, not for games, but this time it's for actual simulation and using different softwares. And I think what motivates me is that once you have result and you can publish them in a journal, so that's quite a long process actually. And this is not some okay, maybe coming back to your first question, that's not something I was expecting so much. How long and not strict, but how rigorous can be the process of publishing a result. Like it can take up to a year from the moment you think you finished your work to the moment it's going to be published and released to the public, because there is this whole process of other people checking your work and called reviewers and gonna ask you to modify it or improve it in many different ways possible. And that's something that can take a bit of time. And
But then when you get that
But
acceptance,
yeah, exactly. But once it's out there, it's very satisfying, and that's what gives us, or me in my case, the motivation to then make some progress every day with this final end goal that you can say, oh look, this is my work. I'm very happy to
Yes.
present it and to see that other people are using it afterwards.
Yes, absolutely. And so you will soon enough finish your PhD. So what is next for you? What are your objectives for the future?
So my objective for the future, that's a good question. So I would like to continue working in the same field, same area. I think this quite suits me, and I really enjoy these themes about studying water resources in mountains regions. So I would like to continue in academia. And usually a way to do that is doing a postdoc, which is a research position where you work on a research project that and then this is like the next step after a PhD. So you can't become a professor directly, or this is almost impossible. So you have to do more research project. And so in my case, I plan to do a postdoc at least here to start with, and then perhaps I would do a postdoc in another group at some point in the future. I'm not sure where. I have few ideas of where I would like to go, but it requires some good thinking, and also you need to think of, okay, what is the next research you want to do from what you learned during your PhD, and from what you think is the most important aspect to dig further.
Yes, because this is also your chance to become or start becoming an independent researcher.
Yeah, exactly. So at some point, you should be able, or you should try to get your own funding, which means that you will write a research proposal. Means like it's like something that you say, okay, I would like to do this research. This is what I expect would be the result, and this is why is it important to do that. And then in exchange, if this is successful, then you will get research budget funding from a funding agency or a government science foundation, etc. And that's a bit how you get a bit more independent. Otherwise, the other option is to have a position on others people project that have within the project, like postdoc positions, for example.
Exactly. Now, I would like to finish this part with the following question. If you could meet teenage Achille again, which advice would you give him?
I would say maybe play a bit less video games, because you will spend a lot of time in the computer anyway in the future. And also go skiing even more, because the snow conditions were better in the past than now, and they will even be worse in the future. So make the most of the mountains back then. Yeah, I think that's it.
I think that's a good advice.
Yes.
To seize the time.
Yeah, exactly.
So thank you so much for sharing your story and how you became a hydrologist. So now for our segment, this or that, I will ask you several questions that have two plausible answers, and we'll see how many you can get right in 1 minute.
Okay.
So today, in our this or that segment, I will ask you who invented or is responsible for the discovery of something. I will give you two options, and we'll see how many you can get right.
Okay.
Ready?
Yes.
Okay, 3, 2, 1. Okay, the Wi-Fi's foundational tech, Hedy Lamarr or Claude Shannon?
I have no idea. The first one.
Correct. Microwave oven, Percy Spencer or Robert N. Hall?
Robert N. Holt.
Correct. No, sorry.
Okay.
Incorrect. First computer algorithm, Ada Lovelace or Grace Hopper?
The first one.
Correct. Polio vaccine, Jonas Salk or Albert Sabin?
Albert Sabin.
Incorrect. Ballpoint pen, Laszlo Biro or Marcel Bich?
The first one.
Correct. The World Wide Web, Tim Berners-Lee or Vinton Cerf?
Tim Berners-Lee.
Correct. Velcro, George de Mestral or Wallace Carothers?
Sorry, I didn't understand.
Velcro. But our time is up.
Okay, okay. Oof. I didn't know the next ones.
But I think you did a quite good score.
Yeah, I think yes. Considering the...
Yeah, it was not such an easy job, I have to admit.
Not so easy. Yes.
So thank you once again for accepting the challenge, for being here today and letting us in on what a hydrologist is, how you became a hydrologist. So thank you very much.
Yeah, thank you so much for the invitation. And if you have any questions, please just reach out to me.
So exactly, to our viewers, thank you so much for joining us today. If you have any thoughts or questions, we would love to hear them. So don't forget to leave them in the comments. And if you liked what you saw, share it, subscribe to our channel, and next time bring a friend. And I will be here to bring you the next generation of science, one awesome guest at a time.